So, which natural process is the main cause of the ocean currents shown? Ocean currents are very, very complex, but they're pretty consistent on a large scale across the Earth. They're driven by two major factors, water temperature and the salinity, or how much salt's in the ocean. So, our cold polar water, which is very high in salinity, is drugged downward towards the equator. And then as it warms, its density changes and it starts to rise up back towards the polar region. And this circle of, this cycle that continues and continues is called convection. So our answer here is for the cause of ocean currents, it's A, convection, which is caused by the salinity and the temperature of these large bodies of water. We have a drag and drop question to identify the major features of the ocean floor. And if you look at our major features of the ocean floor, we've got a continental shelf, we've got a continental slope here, and we've also got, this is kind of showing you some plate tectonics activity. We've got a subduction zone where the ocean floor is being destroyed, and then we've got a zone of divergence here, a mid-ocean ridge, where the new seafloor is being created. We've got some underwater seamount, some underwater islands, and then we do have some islands here that reach all the way up. Alright, so let's try and identify these. We've got the continental slope. Let's take a look. That's going to be right here. That's the definition of a slope. This is the part that's headed downward. Alright, and then we've got an abyssal plains. The plains, like in America, the plains are the flat spot. That's this area right here. And then we've got a continental shelf. That's up here at the top, the continental shelf. All right, this is the place, in Virginia Beach where the water's not too deep, but eventually, when you hit that continental slope, it is going to get much deeper in the ocean. All right, and we also have our last one right here, the continental rise. All right, so one more time, we've got the continental shelf up here, the continental slope, then the continental rise, and then the abyssal plain. We have a picture of 4 people sitting in the middle of the Great Salt Lake in Utah, just enjoying a card game. And if you notice, they have no floaties on, they're not sitting on a raft, they're just floating in the water with their own body weight. And the reason they're able to do this is one of the saltiest bodies of water in America. And all that salt makes the water so dense that it pushes the people upward and makes them more buoyant. Alright, so let's look at the question. Students made a hydrometer. Alright, we see these 3 objects right here, and they placed them all in a different type of water. In fresh water, the hydrometer sunk. Alright? In ocean water, it was pushed upward by all the salt in the ocean water pretty high. It didn't sink very deep at all. In an estuary is like the Chesapeake Bay. It's a combination of, the rivers bringing the fresh water and the ocean, the salt water. And you can see that it sunk a little bit more than the fresh water. A little bit more than the ocean water, but a little bit less than the fresh water. Alright, so students made a hydrometer by sealing the end of a straw with wax and adding some sand until the hydrometer barely floated in fresh water. The diagram shows what the students observed when they used the hydrometer to test for 3 different sites. Each water sample had the same temperature. Which of these explanation best fits these observations? So why did we get this reaction like we did? And that's because the ocean water is very salty. The estuary water is a combination of salty water and non-salty fresh water. So our best answer here is A, estuaries are less salty than freshwater? No. Estuaries are more salty than freshwater. Oceans support more microbes than freshwater? That's true, but that's not what the question is asking, so please be careful of picking a random true statement that doesn't have anything to do with the question. Alright, salt water is denser than fresh water? Absolutely. That is what this experiment has told us. Salt water is denser than fresh water. C. Which of these describes the most common way that material is added to a continental shelf? Alright, so by material we're talking about rocks. And this is a little diagram of where we live right here. This would be like Virginia Beach, this Piedmont area and Fall Line. This would be up towards Richmond. Right? And a fall line is where the land drops down a little bit and becomes like a flattened coastal plain. Alright, so this coastal plain is just really simple. All the rivers all the way from the Appalachian Mountains have been bringing rocks here for hundreds of millions of years and dropping them off and building the coastal plain up. So which of these describes the most common way that material is added to a continental shelf? Evaporation from a continental watershed? No. Deposition of continental sediments? Yes. That's the depositing of sediments from the continent. So our right answer is B. This diagram is a simple explanation of the effects of water in depth and pressure. Alright, so we got this large body of water and we put 3 holes in it, and we wanted to watch and see how far the water shot out of each hole. Well, at the top the water went out a little ways and then it fell downward. In the middle it went out significantly farther and then downward. At the bottom, this hole shot the water by far the farthest distance. So why is that? And that's because this hole right here is under a lot more pressure from the weight of all the water above it. So as you go farther down in depth of a body of water, the pressure gets greater. And that should be something real easy for you if you've ever gone swimming and dived down to the bottom of a pool and feel like your ears are going to pop. So as you get farther down underneath water, the pressure is much, much more. So this is an easy question. At which which ocean feature would the greatest amount of water pressure be exerted? And that's going to be the deepest spot, this trench right here, like Marianas Trench. So J, trench, is the right answer. Okay, there's really good fishing out in the Pacific Ocean. Alright, and that's what this picture's trying to diagram for you. And the reason there's such great fishing out there is this phenomenon known as upwelling. Upwelling. Because what happens is your colder water that's really rich in nutrients and organic material and plankton and all that kind of stuff is brought to the surface. And when you bring those rich nutrient water up to the surface, then the fish are going to come with it to get the nutrients. So that upwelling brings lots and lots and lots of good fishing to this region, and that's because B, upwelling brings nutrients to the surface. Alright, we got a water cycle question here. Most water leaves the ocean through evaporation from the sun's ultraviolet rays, evaporating the water, turning it to water vapor, and putting it in the air. And then how does it get back to the ocean? Well, it gets back to the ocean from when there becomes too much water vapor in the air and you've got some condensation nuclei, something for the water to bond to and form clouds. And then the clouds rain down the precipitation, and eventually that water, as it rains down the side of the mountain, it goes to streams and rivers and as surface runoff, and eventually it makes its way back to the ocean. So the best answer here is A, surface runoff. The 2 most common ions found in the ocean water. Well, we know that what's in ocean water, you know salt's in ocean water, so the question is really, do you know what an ion is? And an ion is a positively or negatively charged particle. And if you know that salt is NaCl, and it bonds together because of the positive and negative relationship of the sodium and the chlorine. So our best answer here is chlorine and sodium, F. That's what's found in ocean water, the most common ion. Alright, what causes Marianas Trench, or any trench for that matter? Alright, trenches in the ocean are formed from 2 plates colliding, and one of the plates will be higher in density, and it will sink because it's higher in density when it goes into this other plate. So in Marianas Trench in particular, we have the older, colder Pacific plate colliding with the younger Philippine plate that's not as cold. And when that happens, the Pacific plate is drugged under and melted in the asthenosphere, and the Philippine plate is kind of propped upward, leaving one spot right here, a real deep spot in the ocean called a trench. Alright, so what causes Marianas Trench? Let's look at our choices. Swift ocean currents eroding away the ocean floor. it sounds like it would cause a trench, and it's a good, good multiple choice, bad answer here. But let's make sure we read them all. The collapse of an empty magma chamber in a large volcano. No. Excessive boat traffic. I hope you didn't pick excessive boat traffic. Two tectonic plates colliding and one plunging below the other. That's what causes a trench in the ocean floor. D. A student hypothesizes that a sample of rock formed from the ocean sediment. What would support that hypothesis? So if you looked at this rock, what in the world would make you think that this rock came from the ocean? And I hope it would be real easy for you. I hope you would just see all these seashells and say that is an ocean rock, and in particular this is limestone, and it was formed in a shallow ocean bed with lots of shelled animals. So what would help you? A textbook about rock formation methods? That could help, but let's look at all of them. Rock samples from several locations on the earth? That could help. A model of different crustal plate boundaries? Probably not particularly helpful. Clamshells found within the rock sample. That's your best answer. That would support that hypothesis. D is the answer to number 10. Two similar eggs in glasses of water. One of the eggs is floating very high in the water, and one sank all the way to the bottom. If you notice, this water looks a little cloudy, and the reason for this trick, this water is very, very salty, and that salt added to the density of the water and made the egg more buoyant and pushed the egg upward. Alright? So a boat will float higher in the Atlantic Ocean than it will in the Potomac River. Remember, oceans, saltwater, rivers, freshwater. Because ocean water has a lower freezing point, okay, be careful not to pick just a true statement that has nothing to do with the question. More organisms in it, same thing. More oxygen in it, a greater density. So what's the reason the boat will float higher in the ocean? J. A greater density will push the boat upward and make it more buoyant. Determining how the seafloor changes over time. It's given scientists information about the... Alright, so let's look at this real quick. Our picture over here shows how seafloor is constantly being recycled. In the center here, we have an underground chamber of magma rising up at a divergent boundary where the land is being pulled apart. So in this center area, we have our new seafloor being created. This is usually referred to as like a mid-ocean ridge. And since this is a divergent boundary, it then pulls the land apart towards the other continents. When this basalt, this heavy ocean crust, hits the lighter continental crust, it gets subducted or taken under the continent and recycled, and it gets melted. And this goes on and on and on again, and this is new seafloor being created. Alright, so determining how the seafloor changes over time has given scientists information about the circulation of solar energy? No. Patterns of carbon movement? No. Formation rates of the ocean crust? Yes. The answer here is C, the formation rates of the ocean crust. Why is the ice shelf floating? Alright, so if we look at this picture, why is this iceberg floating? And the short answer and the real easy answer is this iceberg is fresh water. It broke off of a continental glacier, which was formed by precipitation, water vapor and fresh water. So in the sea, we have a denser salt water, which is pushing this iceberg upward. It's a really neat picture, and I hope that if you've ever heard that expression, the tip of the iceberg, you realize that when you see a little iceberg, there's a whole lot of iceberg underneath it. Alright, so why is this ice shelf floating? The ice is melting faster than it can sink. The ice is less dense than the ocean water. Yes, B. B is our good choice here. The ice is less dense because it's made of fresh water than the ocean water. When the sea floor spreads apart, like right here, it's spreading apart. It's a divergent boundary, getting thinner right here. Volcanoes and ridges are formed because sediments are deposited where the floor spreads apart and building ridges? No. As the plates pull apart, magma rises to the surface. building ridges. Yes, B is our best answer. It's exactly what happens. We have an underground chamber of magma. It rises to the surface and builds new seafloor, and you'll have a big ridge right there.